Ladies and gentlemen, welcome to Jani.tv. Today we have a very special guest who doesn't need any introduction. I'm a huge fan of his work. And all I can say is his initial work has inspired me to learn Kubernetes and build a career out of it. Way back in 2014, 2015, when Kubernetes was just getting started, when no one knew the spelling of Kubernetes, this individual has inspired me to learn Kubernetes. And his book, co-authored by Joe Beda, Brendan Burns, has helped me tremendously in understanding the foundations of Kubernetes. So he doesn't need any introduction, as I mentioned. And he is none other than Kelsey Hightower, the Kelsey Hightower. And I can't tell how much excited I am to have him on my show. So Kelsey, thank you so much. And a warm welcome to Jani.tv.
Awesome. Yo, happy to be here.
So Kelsey, when I just knew Docker and when I was wondering what the heck is Kubernetes all about and how do I go about it, your initial talks, your blogs, your books have helped me get the foundation, the basics of Kubernetes. And then Kubernetes the hard way has been a terrific resource for me to go 2 levels deeper and understand the internals of kubelet and everything. So thanks for all the great work that you have been doing for the community. There is a huge fan base for you in India and of course worldwide. So I want to start by thanking you for all the phenomenal work that you have done for the community. So my first question, Kelsey, is personally, I was a little bit disappointed when you moved away from being a developer advocate to your current role, because I thought, your customer or community facing activities will come down. But that's not the case. I have seen you being very active in the community. So tell us about your current role at Google.
Yeah, look, I'm a distinguished engineer, and throughout my career, I've always either been in operations or on some engineering team building products or contributing to open source in some way. And I think a lot of people forget that a big part of my engineering approach is interacting with actual people. So whether that's the customer base, if you're in open source, that's going to be hanging out in a Slack channel or back in my day, IRC channel. And a lot of my work has a lot of input from the people who use the software, and that helps me prioritize what to build or what to advocate for on the roadmap. When you're an engineer, you're supposed to do a lot of planning before you start typing. And different people have different ways of planning. Some people do research, some people write white papers, some people do studies. I like to actually talk to people that are using it or use it myself. And so regardless of the role, whether you're a full-time advocate or you're an engineer advocating on behalf of your customers, the work roughly involves the same type of activities. Like you have to go to where the people are. And sometimes that's their office where the whiteboard is and the whole team can rally behind and brainstorm what's available and what should exist in the future. And so I think when the roles switched, a lot of people thought, hey, if your HR title says this, then you should be doing these activities. And for me, I don't think that's been true for a very long time. So at Google, I'm just a distinguished engineer. And my goal is roughly the same. Across Google Cloud, we have lots of products and features. And some of them need to work better horizontally. You can imagine Cloud Run needing to work better with databases and things like security, IAM. And so someone in this role, your goal is to influence everything from compute to databases to metrics. And then the way I go about it just looks very similar to years before.
Absolutely. So once an evangelist, always an evangelist. And I think it's in your DNA to explore, learn, share, and then influence the product teams to build what is good for developers. So Google is very lucky to have you. And that's a distinguished engineer is a very coveted title. And you are the perfect candidate for being a distinguished engineer with your outward and inward focus. So
I want to talk about evangelism for a moment. This is a word I actually do not like to associate myself with. mainly because you can be a very effective evangelist without actually having to use the product you're evangelizing. You don't even have to use it. If you get a good script from someone, you get a good story, nothing wrong with it, but you don't actually have to be a person who cares about the technology or the people who use it. You can just evangelize. It's like being hired to endorse a product you don't use, right? If you have a good director, script, and cameraman, it looks very compelling to see a very famous person evangelizing something that they may not use. For example, they may not even drink alcohol, but they may tell you how great alcohol is when they're really drinking water on camera, right? That can be evangelism. I'm not saying that all evangelism is that, but you can do that and still be considered a great evangelist. Advocacy is totally different, in my opinion. Advocacy tends to be rooted in empathy. You typically are advocating on behalf of someone else. So if you're an engineer and you work on a tool that you also use, the first thing you're going to do is fix the bugs that get in your way. You're going to advocate for yourself. You're going to say, hey, look, I'm trying to use this thing that we're all responsible for. I'm going to stop what I'm doing, and I'm going to fix these bugs by issuing a pull request or raising an issue and doing what it takes to get it done. You'll advocate for yourself in those comments. When the maintainer doesn't think it needs to exist, you say, hey, hold on. Without this fix, this is going to happen. So you're advocating. And then there are people who full-time advocate for a product, usually on the behalf of other people. And so what does that look like? When you go to a conference, when you visit a customer and you say, hey, I really love Kubernetes, but it's not really great at storage. And if that's your area of expertise, you have a few things you can do to advocate on their behalf. Maybe they don't have the skill set to write the code to change the project, but you do. And so your code contributions to satisfy that need can be a form of advocacy. Education is another big part of advocacy. You know, people can't use this because they don't know how. And so then you try to write documentation, and the advocacy piece isn't just saying, here's how great this thing is. Advocacy is going to go down to the empathy level that says, this thing is okay, but watch out. Here's what's going to happen on day 2 and day 3. I'm advocating for you to be successful, so I think you should know these things. That's very different than the requirements for evangelism alone. So that minor correction, I think no matter what your role is, QA, you're advocating for your customer. Engineer, you're advocating for the customer. PM, and even CEO, typically it helps. If you know how to advocate for your customer, then you're going to build better products.
Completely agree with you. I remember 4 years ago when Kubernetes was not ready for running stateful workloads and databases, you were the one to call out saying, don't do this. While being the very vocal champion and advocate of Kubernetes, you called out that it's not a great idea to run stateful workloads. And that's precisely what you just mentioned. You know, you have to empathize with your users and say what is good, what is not. But Kelsey, unfortunately today the lines are getting blurred. There are influencers who are leveraging social media and saying a lot of nice things about products, platforms, and tools. Then there are evangelists who borderline to being a marketing representative. And then you have hardcore advocates like you who totally believe in what they're doing. But unfortunately, these lines are getting blurred between, being an influencer versus an evangelist versus an advocate. But irrespective of what the title is, I totally agree with you that you have to think like your user and empathize with them. The keyword here is empathy. I completely agree with you. And again, Google is very lucky to have you because you are literally the face of Kubernetes and Google Cloud. And a lot of engineers take inspiration from you. So tell me, how did you make it to Google? You have done phenomenal work at CoreOS. So how did you move to Google?
Naturally, I was a big fan of the Go programming language, even during my time at Puppet Labs. Everything was written in Ruby. We started to bring in things like closure for performance. We wanted something under JVM, something that wasn't going to be prohibited by the global lock that you have in the Ruby interpreter. And so we started moving towards Java, mainly because Java already ran everywhere. And then while I was at Puppet Labs, it was very interesting because, HashiCorp was, starting to go beyond just Vagrant. But more importantly, Docker came out. And Docker was kind of the first infrastructure project that I saw written purely in Go. And when you looked at Docker, it was really nice. There was a single binary. You would install it. And it did one important thing. It gave us new abstractions. So config management, Puppet, Chef, Ansible was all about automating, in some ways, the wrong level of abstraction. But at least it was an automation tool. Whereas Docker comes out and it's a new abstraction piece. And when I looked at it, I was a big fan of both the programming language and the things that people were doing with it. So while at Puppet, I was one of those people that was trying to rewrite parts of the Puppet stack in Golang itself. And so the easiest thing you can rewrite is what we call external node classifier. It's the thing where you can look up information about a node to give data to Puppet in order to make configuration management decisions. And the other tool we had was called Factor. It's a little daemon that runs on the machine that collects metadata about the server, what OS, what the user, all that information that is used to kind of generate configuration management code. And I thought the perfect fit would be to redo the Factor application from Ruby to Go just to give ourselves some experience and start making headwinds. And I remember people really concerned because at that point, Puppet was really being adopted in the enterprise. So things like AIX and Solaris were important. And Go didn't have support for those two OSs at the time. And so it was like, you can't do this. And so it was time for me to leave because I felt that configuration management was kind of this disruptor along with the DevOps movement. And I felt like the next generation of infrastructure tools were not going to be written in Ruby. That was going to be over with. I felt Go was going to be the language going forward. Now, as someone really believing in Go, when I went to my next opportunity, I went to a small company called Monsoon Commerce. They're a company that helped people reprice their inventory for places like eBay and Amazon. So at that company, we realized that, hey, they were in the middle of rewriting some of the apps from like Java and Python to Node.js. And I came in as an engineering leader, director of engineering, and I said, hey, what if we try Golang? Number one, we can probably reduce the number of servers from like 600 to 200, mainly by having something a little bit more efficient. And that turned out to work. But there was another thing that was brewing underneath the covers. I didn't want to go full-blown configuration management again. Anyone that knows anything about config management, the simpler your stack, the less custom resources you need to build. And so all we really needed at that time was simple Go binary, very easy to install, but we needed a little bit of config management. So I wrote a tool called confd, and I wrote it in Go. And essentially what it did was it did the most important parts around config management, like the config file and its variables, and it would restart the app. And so I open sourced it and was written in Go. And I was hooked. I was like, this is the way forward. Combine this with containers, and we have the perfect setting. Then I gave a talk at GopherCon about Go, ended up emceeing the conference. And guess what? That's where I meet the CoreOS team, ends up being a good fit. And then there's a bit of the story where at CoreOS, we're building tools like etcd. We have this operating system that's optimized for containers. And now for me, I'm growing big time in my career because they're taking all the distributed systems research, everything around Raft and incorporating that into etcd. When I was there, me and another guy named Eugene, we wrote CNI, like the first implementation of the container network interface, because we needed something really lightweight and was more flexible than what came with Docker. And so we had our vision set on building Google's infrastructure for everyone else. That was kind of our tagline.
So was that Flannel?
So Flannel was one tool. So Flannel was a way to coordinate between multiple nodes, network configs, and it was stored in etcd. So Flannel was just a daemon for that. But we were missing a piece. The container networking interface is something at the very low level. When your runtime, whether it's Docker, we had another runtime called Rocket, and of course Kubernetes will come. But container networking is a very, you have to deal with things like IPAM, like, IP management. What subnets belong to the node? Also, what daemon is responsible for creating the Linux interfaces that are then mapped to those things? And so in the Kubernetes networking model, it assumes you already have something there. And in many cases, that was Docker, right? Docker would create a bridge. It would assign IPs to containers. Not really good at pods, so you have to do some magical workaround. But all you got was what Docker could do. what about more advanced networking situations? Well, you really couldn't do that because Docker's plugin interface at the time was very narrow. You couldn't really do all the things you wanted to do. So the container networking interface was like, listen, we're going to give a plugin. You can write your own. We're going to give you the entire namespace. And what you could do is you can create interfaces. You can set up routes. You can go configure a Juniper device if you wanted to. But at the end of that run, you would just return the namespace and we would attach it to the container. And so we were building tools like this to kind of flesh out the ecosystem. But when Kubernetes became very clear that it was our roadmap 5 years in the future, I knew that there was time for a pivot, meaning I started contributing to Kubernetes on the nights and weekends. I started giving some of those early talks that some of you all may remember, but it was clear to me, this was it. And so eventually I become the product manager for CoreOS, and Alex Povey, Brandon Phillips is like, we finally got on board maybe about 3 to 4 months in that CoreOS would now pivot from building our own tools into a Kubernetes company. And that's where we kind of doubled down. And to get to your question, like, how did I end up at Google? After about a year and a half at CoreOS, I was personally kind of ready for something else. And one of our customers was NASA, JPL in Pasadena. And they were using Kubernetes in their kind of on-prem data center. And so I would go there just from a community perspective to help them understand Kubernetes, teach them the things that we were building. And I really liked the team. And they said, hey, won't you come work here? And so I accepted. I did the interviews. I accepted the offer. And that was going to be my next hop, was to go work at NASA on the Mars mission using open source to help us with the compute side. And of course, my friends at Google called and said, hey, you should give us a shot. Long story short, they made me an offer I couldn't refuse. So I ended up at Google, and I've been there for 8 years.
Amazing, amazing. It must be a tough choice for you to choose between NASA versus Google.
Well, depending on how much money is involved, the choice becomes a little easier. But you're right. It is a tough choice because the stuff that people are working on at NASA, it's very much matches the area of empathy that I have. Like, imagine working on something where you're trying to make sure that humanity can figure out how to explore the universe one step at a time, and Mars being that next step. And so for me, that was very much something that I was looking forward to. But look, Kubernetes and Golang and all the Google technologies, I had affinity for before joining Google. It's very rare that you use a product and you care so deeply about a community before you join a company. So it was very authentic for me to kind of slide in and just double down on things that I had already invested in before going there.
Perfect, perfect. So Kelsey, one of the unique capabilities that I see in you is your ability to write production grade code like a hardcore developer, and also having a solid understanding of the infrastructure, the operating system, and the whole DevOps stack. I think that's what makes you very different, and that's one of very lethal combination: the ability to code and the ability to deploy and scale. Very few people have that. I think that's what got you so far, and it's phenomenal to see how you are putting that to use. So you have basically started your career at Bell South, and then you went to Puppet. Puppet was very hot back then because of the config management, and the whole DevOps was just evolving. And there to CoreOS, where you saw containerization, the evolution firsthand, and then Google Cloud, the hyperscaler. So throughout this journey and your transition from each of these companies, you have seen how DevOps has evolved. The definition of DevOps has changed significantly. Earlier, it was just using Puppet, Chef, Ansible, to using Docker files and Builder and so on. And today, DevOps is very different. So what do you think is the current state of DevOps?
There's two important pieces missing to my career trajectory. One, before going into normal corporate America to work, I had my own computer store where survival was required, right? This is where you don't have enough money to pay the computer store rent or get an apartment, so you have to choose. And so at that time, I'm learning skills for survival. There's no need for corporate training or sitting there complaining that people aren't doing all of these things for my own career. I knew how important it was to invest in my own career myself. And so for me, I felt that technology was so accessible. You can go buy a book and learn anything you want as long as you put your mind to it. And so in that entrepreneurial period, there was a lot of learn new skills, being able to offer new services to my customers. So when you're a business owner, the customer is so important because they are the direct revenue source. There's no intermediaries. You understand what it takes to kind of run that business. I did that for years before joining any of these companies. And so with that background and that context, remember, I'm treating my career from the standpoint of an entrepreneur. And so anything that I invest in myself, I know how to get the return. And sometimes the return is just a different job that pays more money or equity in a startup or something like that. So that's number one. That's the starting of that mindset. And this starts at 18 years old, right after high school. So that is my mental thing that I'm bringing into these scenarios. Before all of the cool companies like CoreOS and Puppet Labs, I spent half of my career working in enterprises like, companies doing payments and financial services, where you're doing change windows in the middle of the night. I'm working at companies that are just watching the knock of something going down in the middle of the night, and then you're paging someone to come fix it. Voice over IP for people who can't really afford the big fancy, phone systems, and now they got to get a small Atrix box. And so you're dealing with small businesses who can only afford 10 phone lines for their entire company. There's a lot of trade-offs you make in those scenarios. You don't have access to the latest and greatest technology. You don't always have access to all the talent in the world. So you got to make it work with what you have. And so some of those are highly regulated industries where you're dealing with people who are very nervous about any change. Some of these companies have been around for 5-6 decades or more. And so a lot of the people you're working with are not responsible for any of the technology choices. And so what you're there to do is kind of maintain things, even though it's not advertised on the job posting. Most people are hired to maintain. We get real confused with this idea that we want all of these people to innovate. It's just not true. Most people are built, hey, we bought Oracle, we need you to maintain Oracle. We bought Red Hat, we need you to patch Red Hat. We're not asking you to create a new operating system, nor evaluate one that's better than this one. We want you to maintain. And so surviving in those environments, learning how to bring in new tools like Puppet. So before contributing to Puppet, I was using Puppet in production at a financial institution when it was still version 0.284, right? So not even 1.0. And it takes a lot of political capital and trust building to get an organization to say, hey, this is very different than anything we've ever done before. We can't even look to anybody else that's doing it because it's too new. And somehow I have to convince them through hard work and a bit of influence to get this thing all the way to production. And when you leave the company, I was able and very fortunate to go back after being gone for 8 years, and nothing stopped. They're still using all the latest and greatest technology responsibly because that DNA has been left at that organization. So when I look at DevOps, luckily for me, a lot of the career stuff that I was doing was before DevOps, meaning I just had to do the work. If you're in ops, you learn how to code so that way you can get the production apps to align with the infrastructure. You just can't complain and say DevOps, something transformation. You can't just say that. You have to do the actual work. And so when the name comes and someone tried to apply that label to me, hey, Kelsey, you're doing DevOps. And I'm looking at that word like, that's just the word. You don't understand what it takes to actually do the actual work, treat your skill set from an entrepreneurial mindset. And when you're on a team, looking beyond the HR title and doing what's necessary to execute. I learned a lot of that in the open source world, right? You're not just a software engineer. If you're a project maintainer, then you do everything. Documentation, QA, you write the code, you market it, you speak at their meetups, you do everything. And so I think a lot of people who've learned DevOps just from the word, not the work, there's a bit of confusion. You join a company. Remember, most people are being brought in to maintain. So you don't understand about the work. You just like, hey, maybe this is just an operations team that just got renamed to DevOps team, but they still work the same. You don't know the difference, right? The team comes in and says, hey, we do the Jira tickets, we use Puppet, we run it, and now we're doing DevOps. This isn't true. There's more to this equation than just the tools or a claim that you just want to improve the culture. So that's why I see all of these buzzwords very different, because I understand that if you take away the buzzwords, the only thing that's going to be underneath there is work. And do you have the skills to do the horizontal work necessary to execute? And if the answer is no, DevOps, SRE, or whatever buzzword you want to come up with won't help you.
Absolutely. The keyword here, Kelsey, is survival. And I completely relate to that. When you start your life to make sure you're able to make the ends meet, the motivation is very different. And you have started from there, pretty much the grassroots level. And that's what makes you very, very special, because you empathize with a lot of folks who come from that background. And I also completely agree with you that these jargons and buzzwords don't matter. What matters is real work. So don't go by titles, don't go by these labels that the industry often puts and removes. They are very, very tactical, very short term. So thanks for sharing that perspective, and your story is very inspiring, and that's what makes you very unique and different. So now I'm going to switch gears and talk to you about slightly more technical stuff. So I have been personally a huge fan of CoreOS, and they were ahead of their time, because when containerization was just picking up steam, having an operating system that treats containers as the first class citizen, and you don't even have Vim in the operating system, it is just meant to run containers, was phenomenal. It was ahead of its time. But after Red Hat has acquired it, I must say I'm a little bit disappointed, because they changed everything. And today, the CoreOS that Red Hat uses for Fedora and RHEL is very, very different. At the same time, in the ecosystem, we haven't seen a real good open source alternative to CoreOS. I had hopes on Flatcar Linux, but that also diminished after Microsoft acquired Kinvolk, and I don't see a lot of progress. So what is the current state of container optimized operating systems, and why are we not seeing alternatives to CoreOS?
Well, number one is because of progress. The progress tells us we don't need it. You may want it. You may align with the philosophy, but it ain't required. And CoreOS was phenomenal, but it's not the first time. FreeBSD, jails, Solaris zones, right? We've been here before. I think what CoreOS did was package it up, bringing Docker into the fold. Docker was a new approach. Many would say at the time, Docker was not superior to FreeBSD jails or those things. People feel that the operating systems of today still have to catch up to the operating systems of yesterday. We haven't necessarily solved that problem 100%, but what Docker did was super important. It moved up the stack. We're not talking about just a pure low-level operating system concern. We're talking about things that real developers who build apps need. And so the important component to survive from that time was probably the Docker image. Lots of people talk about the kernel and namespaces. Great. These are great implementation details. But the thing that stayed was the image format. Why? Because the image format was the piece that allowed us to decouple from the operating system. So the whole goal wasn't just to have a better operating system and then couple to that. The goal was to decouple from all of them. So it just doesn't matter. You can just use Cloud Run. You can use Knative, Cloud Foundry, Heroku, Kubernetes, App Runner. Doesn't matter now, because guess what? So now we know the most important component is that image format. I'm not saying it's the piece that you can monetize the most. I'm not saying that. I'm saying it's the most important component. It's like language. It's hard to monetize language unless you write a good book or a good movie. You got to put something with it. So the container image is so important that it transcends all of those things. So that piece is there now. Good job. Now what Kubernetes represents is a workload API, a place for the whole community to experiment. We have deployments, we have replica sets, we have pods, we have Knative. So now we have all these workload APIs. My bet there will be 100 of these in 10 years. No one's ever going to agree on how to do a batch job. No one's ever going to agree what a cron job should do. But the good news is now we have infrastructure to express all of these ways of doing it. There are some common layers like placement onto a server, CPU memory, disk space. You're going to need those. But now we don't have to have everyone try to also build that layer. Now you can just focus on your own workload spec. Beautiful. Container image and workload specs. Those are the things that are important. So if you believe that, then you don't even think about the cluster anymore. Do you really need Kubernetes to do that? It can go away. Do you really need Linux? Do you even know it's there anymore? It can go away. So if you're someone building right now, you don't have a lot of incentive to make a better CoreOS. Why? It's going to get buried anyway. And so there are some CoreOSs out there, but they're hidden. Container optimized Linux from Google. That's the default thing that's underneath everyone's Kubernetes cluster. No one talks about it. Why? Because it just works. It's not important. It's small, as it should be. So I think CoreOS did a good job. It showed that this was possible. And it's used in a lot of places. So I don't think it's going to be a standalone thing that we have to talk about very much because we've kind of completed the mission. And so whether we do come back out with another open source project, I think what we've learned is that the idea is now open, is being implemented in things like all of these cloud hosted workstations and development environments. What do you think that is? That is a Kubernetes or a CoreOS like thing. So it's not that we have one distro, it's just now it's everywhere. That now means that CoreOS was ultimately successful, so successful that it's now able to go away.
I completely agree with you, but think of a scenario where customers are running container workloads on Kubernetes in enterprise. Why should they use a heavyweight Ubuntu or a RHEL? Why can't we have a lightweight, for example, imagine running COS, the container optimized OS, just default for GKE in enterprise on my own server.
Let me tell you why. Because when I was at CoreOS, we went through this. It's easy to understand. Here we go. You're an enterprise. You buy hardware that you expect to last 5 to 10 years. Okay? So you go buy an HP blade rack, right? You get the chassis, you mount it up, and it has firmware. You ever apply firmware before? On the operating system, I need tools to apply firmware to the baseline. And guess what? Those tools are sometimes written in Perl because they're 15 years old. So now if you have a base operating system like CoreOS, where are you putting Perl? You're going to put it in a container? What version of Perl are we talking about? The vendor needs to test all of these things together. So if I'm HP, think about it. You're HP. Let's have empathy. You're HP. You built this hardware. You have this Northbridge chip. You have this sound card. I don't know why you have a sound card on your server, but you do, right? So you have all of these components, and now you got to go certify because the enterprise says, we need you to test every minor update to make sure everything's going to work. So now I got SUSE, Red Hat, Ubuntu, all of those versions, LTS. I got Fedora. I got 6 or 7 of these things that I may have to make sure it works. I don't have time to go and test CoreOS or any of these. Why? Because when I go to those, they're saying we're only doing new packages. No. We need a very old version of libc and OpenSSL. And they're like, we don't do that. We keep moving forward because the OS is the thing. And so you say, all right, well, we're going to get an old container. Again, you try it. So you say, all right, the old container has the old versions of IP tables to make this weird Perl thing work. Guess what? Old IP tables does not work with new kernel. So it's broken. So if you're HP selling hardware to the enterprise, you can't keep up with this. And so you can't support it. So taking something that is thin and minimal means you also strip out all the legacy stuff. Who's going to maintain 12 versions of Perl? Because that's just HP. What about Dell? What about IBM? This is not sustainable. So companies like Red Hat have to make a decision. Red Hat Enterprise Linux is important because they've already said, we will maintain this thing for 10, 15 years. We will do all of this low-level details for RAID controllers and PCI adapters. We're going to do all the work at the OS level, including making sure the drivers work with everything else. That's not a scalable approach. So if you want to have an operating system that's thin, you're going to miss that. I promise you, because we did that at CoreOS. We ran into that so many times where someone says, oh, we love this idea, but we can't apply firmware to our OS because the runtime or the tools do not work in CoreOS. And now we're sitting there saying, oh my God, we would actually have to try to test 500, 600 hardware configurations. You know how much that will cost us? So when you look at the price of Red Hat Enterprise Linux and you think it's too high, that's what you're paying for.
Absolutely. Totally agree with you. I think we need that proven, tested, trusted stack, which is a combination of hardware and software. Totally. Perfect. Thank you. So, Kelsey, your Kubernetes the hard way is like the go-to resource for many Kubernetes engineers. There are multiple folks, people trying to do it with Vagrant, people trying to do it with multiple other environments. So a lot of experienced folks go back to that repo and look at the inner workings of Kubernetes. But when you look at an aspiring, budding Kubernetes engineer, he's getting overwhelmed with the complexity, and that's been the case for a long time. So how do you think this is going to be simplified, or what is your view on this whole complaint of Kubernetes is complex?
Yeah, humans are complex. Most people don't even understand how they work. You don't even understand how you work. You don't understand how your mind works. You don't understand how your heart works. You don't even understand. You wake up every day and you're just happy that all of these systems, without your input mostly, without your conscious input, function. That you are complex and you live with it every day. So when you go to the doctor, you're the doctor. I need you to understand how I work, at least how parts of me work. I don't want to go to a heart surgeon that doesn't understand the complexities of the heart. Now, we could sit around and complain that the heart is too complex. Great. What do you want to do about it? It's complex because it evolved and it requires this level of complexity. I think people forget, if you just have one server, that's it. Then don't install Kubernetes. Just don't. Do some SSH script and be finished. You can ignore everything. But the world has evolved. Now people are saying, we want hundreds of servers. We want high availability. We want to have the apps move even if a machine were to die. You want it to automatically recover. You want to have memory be shared. You want to overcommit resources and then have something smart enough to evict something that is not important. This is very hard to do. This is hard. You can't do it by yourself. If I gave you 1,000 servers and I told you to manage this stuff in real time, you can't do it. I guarantee you can't do it. So what you're going to do, you're going to build tools. And you're going to build tools that will eventually evolve to meet the level of complexity that has been asked of you. Kubernetes is an evolution of that complexity. It actually isn't complex enough. That's why we still have gaps, like running stateful services properly. So all it's done is evolve to where we are. And so when you look at Kubernetes, yes, you have a complex scenario that requires a complex tool. And if you want to be the doctor, now if you just want to be, the customer, you're right. Kubernetes is complex and you deserve to complain because you don't, I don't want to know how any of this works. So for you, you should be looking at Lambda and Cloud Run, maybe GKE Autopilot, whatever, right? That's for you because you don't want to know. But if you're a Kubernetes engineer, you're a doctor and you want to say that you're going to have to go to medical school. So welcome to medical school. So the whole point of things like Kubernetes the hard way is to be one of the textbooks. So that way you can learn this stuff is complex. Here's why it's complex. But I think the historians, we have to tell people that compute has evolved and it evolves in kind of parallel timelines. There are some people who still only need one server. And so for them, they're going to be more concerned with things like faster CPUs, faster memory, disk controllers, more powerful GPUs. So in their world, they don't need multiple servers. They just need one server to get better. And it is getting better. But they don't need the complexity that Kubernetes brings. And so that's how I explain it to them. You're dealing with something complex. And finally, just finally, you're getting a tool that embraces that complexity and doesn't try to hide, right? When I think back to Puppet, Chef, and Ansible, it only embraced a subset of the complexity. In those tools, we still treated the world like a bunch of single servers. And so you would take a server and give it a role and then run Puppet on it. So it's almost like SSH, but better. Now what we're saying is that it's more complex than that. We have to think of new concepts like clusters and distributed systems, so that way we can actually manage this stuff with the same type of complexity that we're dealing with.
Totally. As they say, to drive a car, you don't need to understand how the car functions. You don't need to be a mechanical engineer or an automobile engineer to learn how to drive a car. So it's very, very similar. I love that answer. And Kelsey, you are famously quoted in multiple articles and multiple conversations on the statement of Kubernetes is the platform of platforms. And I just loved that when I first heard, because it is the meta platform and it is meant to be that. But, even after 6-7 years of Kubernetes being in existence and reaching that maturity, we haven't seen a real developer platform or a developer layer that enhances the experience and gives a PaaS-like experience to developers. So do you think there is still an opportunity to build an abstraction on top of Kubernetes? And what is the current state of platform on top of Kubernetes?
Oh, you have. But no one wants that. Not everyone. That's the problem. Heroku has been here forever.
Right.
Cloud Foundry has been here forever. App Engine has been here forever. So why are you not using those? Aha. Yeah. You don't want to use those, right? They all have some weird limitation in some way. So you don't want that because you already had that. So to ask Kubernetes to become that doesn't make any sense. That's not what you want. Linux has been around 30 years, right? And people still use it for certain things. So to me, Kubernetes, the reason why I say it's a platform for building platforms, I told you earlier, there are going to be 100 of these PaaS-like things because no one's going to agree. And so some people really want something that just does a great job for batch processing. They want a batch service. That's not Kubernetes, but Kubernetes will give you 80% of what you need to build a batch service, right? Great. And then you will present that service as a new thing or something you can install. So we have tools like Portainer, right? If you go look at Portainer, you layer it on top of Kubernetes and you can use its high level abstractions to deal with it. There's tools like Rancher, and I can go on and on. So there's already tools. The thing is, we don't have global consensus. And so when I think about these infrastructure tools, we know we need an operating system, and we have AIX, Solaris, Windows, Linux. We're starting to get, after 30 years, we're starting to get global consensus that Linux can be that layer. And we're done, right? Most people, can add plugins or modules to Linux to make it what they want. You can shrink it down to a phone, or you can scale it up to a beefy server in the cloud. No problem. But when we say PaaS, we've already had some attempts that not enough people agree with. So a lot of them are gone or out of business, or people are shifting away from. Because what we found is that the 80% use case looks like Kubernetes. So now that we're moving up the stack, it looks like people will agree on a distributed system that has customizable workload definition and hooks like emission controllers and storage plugins. People have agreed that, okay, we're willing to go to this level of abstraction, meaning it's not quite a PaaS. It's not quite Heroku. You can use it in some ways, like you do one command to deploy a deployment, but it's not going to do everything like Canary and all the stuff that we're discovering as a community at this stage. So that's just where we are. So guess what? In the next 10 years, it's been 8 already. So maybe in the next 10 years or so, someone's going to come up with another 80% that we will agree on. We all may start to agree on what Canary means, and we all will just do that. So I think that's the pace, right? And then I promise you, in that 15-year time frame, people will forget how little we had at this time frame, and will complain that the new thing, even though it does way more than what Kubernetes will do, still falls short in certain problem domains. And people will ask, where is, the thing that's even easier than this? And then we will make progress again.
Agree. I have been in the industry for about 30 years, and this is one question that is repeatedly coming back and being asked by developers and organizations. So on that note, Kelsey, one of the other things that I'm noticing in the ecosystem is proprietary implementation of container orchestration. On one side, we have Kubernetes, managed Kubernetes, that is becoming almost like the gold standard. But at the same time, we have things like the app runner, the container apps, on Azure. Then we have Google Cloud Run. All of them are not exposing Kubernetes API. They are proprietary, to name like ECS and Fargate and so on. So this fragmentation and creating opaque black box services, personally, I think it is fragmentation and deviating from this portability and the conformance that Kubernetes has promised. Do you see more and more of those proprietary black box services for container management evolving?
So remember, without this, you will get no progress. You will stagnate, right? We should have just all been using Red Hat. Why are we doing CoreOS? Why are we doing Ubuntu? So here's the thing. We already know Kubernetes only solves 80% of this problem. Probably not even that much. I'm being generous. So where does the 20% come from? Number one, there's a whole group of people you left off. Every system administrator, every platform engineer is also building proprietary systems at their companies, right? All of those scripts, those custom controllers, those operators, all of that's proprietary. All of that is also black box, right? You build those 20% pieces because you can't wait, right? Your company's like, hey, we're excited about Kubernetes. They install it, they get it running. They say, oh, whoa. It's missing stuff. It doesn't integrate with this. It doesn't integrate with that. We're using a different thing for this. We have a different storage array. We're using NetApp, blah, blah, blah. So what do? Do you wait 15 years for everyone to agree on how to interface with NetApp? Or do you make your own NetApp plugin? So every company in the world is building proprietary system on top. Sometimes we start to use common libraries like Chef, Puppet, and Ansible. That's a common framework, but there's typically some glue on top or custom code that's being written to operate those things. So everybody is doing this. Now, if you're a big cloud provider, people are not just paying for you to run open source Kubernetes. So if I run open source Kubernetes in the cloud and you come there and say, hey, where's the IAM integration? And I say, you need to go do it yourself. You'd be like, what? That's a lot of work. Where's the load balancer integration? Go do it yourself. That's not much service, is it? So the cloud exists to provide value and a service. Some people think the value is just taking pure open source and hosting it. That doesn't make any sense because then every company will be out here building even more fragmentation. So now what we get, in many ways, if you think about it, less fragmentation. You can say Cloud Run, which is an opinionated 20% on top. Guess what? Cloud Run doesn't even run on Kubernetes. It's gone. But what you end up with is the same workload APIs, the same container images, and very similar workflow, but we close the gap in a very specific way. Amazon has their own opinion with App Runner, right? Very similar. They got a UI, they got IAM integration, they got billing supports, metrics, logging. All of these things are not in open source. So what's going to happen here is that if every big provider, every independent company in the world were all to try to go get consensus at some CNCF meeting, no one's going to agree. You're not going to agree on what the next 20% shall be, right? You're going to start fighting like, oh, we need this extension. So I think the right thing to do is to say, all right, we've gotten to the 80% use case with Kube. The future is going to be that 20% gray area. We don't even know what it is yet. So what's going to happen is different organizations, different independent companies will all experiment. They're going to give talks about all the stuff they did to Kubernetes to make it work. At some point, one of those is going to emerge to become the next 80%. And most people will just rebase on top of that. They're going to get rid of their custom thing. Maybe even one of the cloud providers like, all right, now that everyone is doing this, remember, there used to be multiple Kubernetes layers before, right? Mesos, Kubernetes, there's still Nomad. There's a lot of stuff that's out there, but it's starting to consolidate. So we're just at that phase. So yes, you could think about them as black boxes. I think of them as progress. And we need people to experiment. We need people to share. And if they do a good job, one of those is going to become the standard for everyone else.
Agree. I think the 20% is what is being addressed by these non-Kubernetes based services. Now, on a similar note, serverless on Kubernetes honestly hasn't picked up as much traction as I personally would have loved to see. For example, when Knative came, cloud events became a standard. I was hoping that we are going to have a Lambda alternative in a much more transparent form running on Kubernetes. But today, serverless is not like a major workload or an environment on Kubernetes. So what did we miss, and what is the future of serverless on Kubernetes?
I knew that wasn't going to work. Early, I was like, you can't do it. It's not possible. People are like, yeah, you can. You can run a function on Kubernetes, like, so then you don't understand Lambda. People think it's literally like, run this code for me. That's not what Lambda is. Lambda says you don't have to think about the cluster. So if you have a cluster at all, then you've already lost. You cannot do it. Because the philosophy isn't, we can copy the Lambda API. Sure, you can. But can you really give me the billing model? Can you really give me the SLA? Can you really host it? Can you give me all the regions? Can you give me all the deep integrations? So what you end up in the Kubernetes world is you install Knative. You have some eventing framework. Remember, I already told you it's going to be 100 of these. So let's say you did a good job. Some people will still want Lambda. Some people will still want Cloud Run. Not everyone's going to want Knative because we all don't agree that Knative even does enough. And let's just be honest. If you look at Knative and you zoom in, it looks like a regular pod that auto scales based on HTTP requests. And if you're running on Kubernetes, you look at that, it's like, dude, that's not important. I'm going to run one pod and I'm going to be fine. Why am I dealing with scaling to zero? A lot of people in the Kubernetes community, we don't have a problem scaling to zero. That wasn't the biggest challenge we have. Some people just still want the app to work. We're not at the hyper optimization stage where we need to scale to zero, then back up again. So while it's cool that we have it, that doesn't solve the big problem in the Kubernetes world. And even if it did, it's just 1 out of 100. And so I think the thing we're missing is we don't understand serverless. People want CDN. No one wants Akamai. I mean, maybe there is someone. You don't want to go get some binaries from Akamai and install it on 500 colos and say, look, me, I got CDN. No, you don't have a CDN. Now you have a problem. Now you got to manage all of this stuff and negotiate network peering agreements with every. That's not what we're talking about. So you cannot do it. Now, maybe you're a platform team and your organization would love a serverless-like API. So we got to be clear on what that means. Now, you might be able to do it. You take Kubernetes, you take Knative, you build a really great UI, you integrate deeply with everything so no one has to touch it. And so your developers say, hey, we just want to keep deploying stuff. And you say, hey, we're out of capacity. It's like, what? Yeah, we're out of servers. It's like, why? What are you talking about servers? I don't want to know about servers. It's like, yeah, but we're out of disk space and servers. It's like, see, now you're breaking the serverless promise. I'm telling you I can afford to pay. You need to go and handle the capacity abstraction for me. So I think this is why this is challenging, because we always leak up the people part, we don't have enough capacity. We have to make trade-offs. We need to get someone to buy a new disk because we're out of disk space. That's not what people want. So in those cases, they want to just use serverless where that is shielded from them.
Makes sense. Totally. On a similar note, there is a lot of interest and excitement around WASM. And it is now positioned as the parallel to run C and containers, and Kubernetes is expected to even orchestrate WASM modules. So how do you see this new thing? And personally, for me, it is like reinventing the wheel, because we're going back to the same challenges of defining OCI, run C, and defining that standard, and how do we manage stateful. All those questions are coming back with WASM. So what's your personal take on Kubernetes and WASM?
Well, depending on who you talk to, I think is the challenge here. So the thing that after a lot of conversations recently, the thing I'm starting to understand and something that finally makes sense to me, in the browser, in which I think a lot of this stuff originates, you need a way to sandbox interactions between multiple web pages and tabs. So they create a very restrictive sandbox. There's no reason in most cases that a web page should be doing things to your local system at all. That's dangerous. So of course you can lock it down and remove all of these things like threads and networking and all of that stuff. It just makes sense. And then if you take that model, what's the next area that it makes sense? It makes sense for plugins, right? Because essentially is the framework place for plugins for a browser. So if I put it into a networking device, or if you're Cloudflare, instead of using Lua, you take the WASM runtime and say, hey, anything that can target WASM, so not just Lua, not just Rust, not just JavaScript, you can write plugins to a simple sandbox that allows us to be as efficient as a browser. It makes sense. It's like, great. So now you say, hey, let's go one step further. Now you want to take WASM to the desktop or the server side. Now it's starting to look a little silly because you're like, hey, man, wait a minute. Why are we doing this? Because remember, when I write server software, I want to actually access the server. The server is the king, not the runtime. We don't normally, we don't write software just for the runtime. Maybe you're just doing a simple HTTP API. Maybe you just target JBoss or some application server. But typically when you're writing server-side software, the server is kind of the point. You want to use the GPU. You want to use the accelerator that's on the machine. So the runtime needs to expose these things, whether it's system calls at the kernel level or whatever you want to do to optimize. That's part of the contract. So if you take WASM and you move in and say, hey, look at this powerful sandbox, but the sandbox is so tight that you can't do anything. Like you can't make a network call. That's kind of important for most server-side software. You can't read from the disk. They say, well, Kelsey, you can do all those things. They're like, show me how. And there's all these weird workarounds and doing this kind of, and you're saying, look, man, that is not my primary problem. So if you're serverless, then you do like the idea of a restrictive sandbox, right? App Engine with this approach. We had these custom runtimes that created a sandbox at the runtime. So it was a special version of Python. You couldn't do everything that normal Python could do, but you could do enough within the App Engine context. And for some people, that was fine. For others, too restrictive. So now that we're in a world where we have containerization and we have tools like Firecracker and gvisor, those go a different way. Those say we can create sandboxes that are tight but flexible. WASM says we're going to make a sandbox that's tight and today is inflexible. So my understanding now is WASM is more of a new computer architecture. We have ARM, we have Intel, and WASM will become a new computer type. And the WASM community has a very small instruction set in comparison to ARM and Intel. And so with WASM, it's so small that it's safer, as far as we know. It's less to have to deal with. The problem, though, we don't have threads. We don't have the common things that all of these runtimes have evolved to support. So that's why we have to do all of this work to say, if you're writing code, you need your compiler to be able to spit out a thing that understands the WASM instruction set. So WASM is an instruction set. It's a different type of computer. If your app can run on that kind of computer, then you're fine. You get the benefits of security, isolation, sandbox, but that computer today doesn't do everything that an Intel or ARM architecture allows you to do in terms of interfacing with the OS. So over time, I think they're going to do a great job as plugin for networking stacks, extensions for your database. Maybe we start running store procedures using WASM layer so that we can use store procedure in any language. This is great. If WASM were to stop there, they did a good job. I think the ambitions of this hype cycle is that WASM becomes a universal computer. And I think, and I may be wrong, it's not going to work because there's just too many things that people want to do now and we don't even know what they want to do tomorrow. And so unless the WASM community can be as fast and nimble as the ARM community and the Intel community, then they may find themselves lagging too far behind to be a general purpose computer architecture that you would want to target by default. So I think that's the big challenge that they have. Now, all this other stuff to me is a bit of a distraction. When people start talking about WASM paths, you're leaking implementation details. It's like saying use Lambda because of Firecracker. Just because you're using WASM as a sandbox doesn't make it more appealing to me. That's just your implementation detail. That's how you're going to keep it cheap, affordable, and fast, and hopefully secure. But that's not telling me of any value. What value does that give me that now I have to give up standard languages and frameworks because you have chosen that your sandbox is the core of your platform? That's not what most people care about. So unless they can close the gaps between what their sandbox is capable of and what developers want to do, we already know how this works. Developers are going to say, I'd rather just use a real runtime because I don't want to rewrite all of my code from what I'm currently doing. So that's my thoughts on WASM. It's an architecture, and there are people who are really excited about this new sandbox allowing more serverless-like platforms to blossom, and we'll have to see what happens.
Perfect. Very, very enlightening, Kelsey. I really love the analogy of there is Intel x86, there is ARM, and now there is WASM. And if it evolves to become as stable, as mature, and as pervasive as ARM and AMD 64, then we have something to look at. Otherwise, it's a workaround and it's always trying to make things, it is like, not built in, but bolt on. So perfect. I learned a lot from this discussion. So moving on to the next one, another buzzword that is kind of shaking up the world and even the DevOps community and the Kubernetes community is generative AI and what AI means to DevOps. I have seen many tools like K8, SGPT, and AIC. We have seen IAC, which is in infrastructure as code. Now there is AIAC, where you leverage AI to generate infrastructure as code. So what is your view on this whole AI thing and how does it influence the DevOps and the operators world?
So I'm going to start at the low level and then work my way up. At the low level, forget generative AI for just one moment. Whenever we see someone writing a lot of code to do something, what do? We make a function. And then we try to figure out the right parameters for that function so that instead of writing 50 lines of code, you write one function with the right parameters. Functions evolve and they become standard libraries. Makes sense. And so when I look at generative AI, it tells us that we're probably dealing with the wrong abstraction, right? So yes, it's impressive that you can generate all of this boilerplate, but what does it tell you? It tells you that we should not ask anyone to be writing such boilerplate in the future. So anything that you can generate and that you would accept, then we know that that boilerplate should be moved into a library or a framework. That's what it tells me. So everything that people are excited about, we should make it a library or framework. Then there will be nothing to generate because the only thing that will be left is the interface for the human to make a decision. What TLS encryption do you want? The ChatGPT cannot generate that. That's something you have to answer. And so I think when it comes to compute, like creating YAML files or generating code, this stuff is symbolic programming, meaning you don't need to guess. I think people forget that these things are trying to generate something that's probable. It's a probable outcome that you want your Kubernetes manifest to look like this. So the probability is probably very high. But when you already know the answer, there's no need to guess. It's silly. So what I think we need to do is realize where ChatGPT is being used in the symbolic workflows and make better high-level frameworks and SDKs. So how would this look like? If you're writing a bunch of YAML and you're like, oh my God, we're doing too much YAML. The old way was like, maybe you make a template. You have things like Helm charts or whatever. So Helm will be a symbolic approach, meaning you know what's safe. You know what parts of Kubernetes you want to use. And so you lock it in almost like a policy. And then you expose a very thin interface like key value pairs that then allow the template to be used. This is a symbolic approach. And honestly, it's probably the safest approach because you can reason about it. You can run static analysis on it. If you were to take Helm away and say, let's do it with ChatGPT, now you're moving away from symbolic programming and you're moving into a world where you're going to try to guess, right? Someone says, write me a pod for my web app, and it will generate what it thinks is the right idea, what it thinks. And you don't know Kubernetes, right? Because you're like, I don't want to learn Kubernetes. It's too complex. I don't care. So you say, oh my God, look how smart ChatGPT is. So you copy and paste. Turns out there's a vulnerability that came out yesterday. And the data set that ChatGPT was trained on doesn't know about this. So now you're in trouble because you're guessing. That's no good. What you should do is probably look at that manifest and say, hey, this is a good starting point. And then maybe other tools can come in like linters or tools that are trained on symbolic things like this is actually unsafe. I don't need to guess. We know it's being exploited right now. You run those tools over that output and you ask yourself, okay, let me make some changes to this. That's the way you have to think about it. So let's move up. The higher you go up, you get to the human piece. So there's another perspective of like, this is the new baseline. So whenever I see, the same engineers have to craft emails to each other. Typically, when I'm communicating with someone, I'm trying to take me and my understanding of my situation and express it to you. And so maybe you don't really have anything important to say, and it's also boilerplate. And so you use ChatGPT to generate an email. It's like, if you have nothing to say, there's a problem. And so using ChatGPT to generate all this boilerplate, you have nothing to communicate. It's like when I listen to music, the song means more than just the words and the melody. I'm assuming this person has lived a life and they're taking that life and they're expressing their life in the music. That's why we appreciate it. It's important that we understand the human struggle and have empathy for it so we can hear it in the music. That's why it makes us feel something. But if you just tell me that there was no experience behind it, there was no lived thing behind it, and something just trained to make it, maybe it's still a good song, but I don't know if I feel the same way about it. And so for me, ChatGPT and all this generative AI, I'm thinking about there's two choices. There are people who will sit in front of their computer screen and click their whole life away. There's another group of people who will go outside, and they will be the people who generate the data set. I want to be the person who lives live and walks around and takes those photos that your model will be trained on. But I will be the person that will stand there and get to observe the world as is. And I'll take a snapshot for you. But I want to be the person who lives in the real world and generates the data set. So that's my opinion. It's not a bad thing. I'm just going to personally regulate it to a tool and not something that I should, look at as the thing that will control me.
Exactly. Another level of automation, but not a replacement. Perfect. So we're almost at the end of this interview, Kelsey. I personally consider you as one of the most productive technologists and engineers. You have been doing a lot parallelly. I wonder how you manage so many things, where the energy comes from, and one of the most productive individuals that I have been seeing. So please share one productivity tip with my audience on how you actually, manage your life and your professional career.
I'll say no. Seriously, like when you say yes, you're borrowing time from the future because you got to deliver on that promise. So these days I look around at all the stuff. So number one, when you're working on something, pay attention in the moment. You're at a company, they're using PHP. You can get distracted because other people are using Java, Golang, Node.js. But if you were focused in that moment and you go super deep on PHP, you learn how the compiler works, the runtime works, the bytecode, how it's generated, the language syntax, how it evolved. You learn the history. So then when the time comes and you have to pick up Node.js, it's going to be different. There's going to be a lot of similarities. And so for you, you get to take that experience and save yourself years of trying to learn the fundamentals of everything. So I got 20 years of fundamentals behind me. So when some new technology comes out, I typically need about an hour and a half with my hands, a few conversations with the experts. And then what I can do is start to map my experience and fundamentals to the new thing. And so at that point, I feel like I'm qualified to at least have an educated opinion and in many ways contribute something meaningful to the discussion. And then I can just put it down. So I don't need to spend 5 months or a year, getting super excited about Istio when I know that there's just a proxy and configuration being moved around. And if it's helpful, it's helpful, but I don't need to go crazy about it. And so that's how I get to be productive. So I can say no to the hype, stick to the fundamentals. That's my thing. And then also I try to work on things that I actually care about. And that's why, going back to that evangelism thing, a lot of times you're asked to talk about stuff you don't care about. And it shows, right? You ever go to a talk and can tell this person really doesn't want to talk about this. Maybe they didn't even make the slide deck, but they got to do it. That's different. When you're talking about or working on something you care about, motivation is the secret sauce of productivity to me. When there's something you want to do, you don't need a lot of outside pressure and forces to get you to do it because that's already inside you. So I try to my best to try to focus on things I literally care about, because when I do, I think you can see the passion. I tend to try to get it right the first time, and I have the drive to keep going. And then I go to sleep on time. I think that's the other thing. I think we get so enamored with growth. I have personally learned that that's not sustainable. Anything that grows forever eventually dies. Balloons eventually pop. And so I've chosen a more sustainable path that I only have so many cycles. I try to use them wisely. And I learn how to say no.
Saying no. And the key takeaway here is the motivation is the secret sauce of productivity. So staying motivated, doing what you love is absolutely important. So Kelsey, thank you so much for spending the last 45 minutes with me. This has been so much valuable to me personally and also to my community and my audience. It's been so much enlightening and valuable discussion so far. So thanks so much for joining. I'll continue to draw inspiration from you. I'll continue to learn from you. And thanks again for all the great work that you've been doing for the community.
Awesome. Thanks for having me.